Je luistert naar het tweede gedeelte van een gesprek dat ik, Frans Pollux, samen met vriend Miel Theeuwen had met een Canadese uitvinder, THANE HEINS. Die beweert een apparaat te hebben gebouwd dat alle wetten van de natuurkunde tart en een soort van oneindige bron van energie is. In ieder geval hele rare dingen doet. Zijn volledige verhaal over hoe hij tot die ontdekking komt en wat hij met die ontdekking gedaan heeft en wanneer we het misschien op de markt kunnen gaan zien, is te horen hier op YouTube. Dit is deel 2. Deel 1 is er ook. We zitten op een terrasje van de Starbucks ergens in de buurt van Wendover. En we stappen in het gesprek als THANE HEINS net heeft uitgelegd hoe hij eigenlijk per ongeluk dat rare apparaat van hem heeft ontdekt.
At that point you didn't have the explanation of how the physical workings, how it actually worked. And then you proceeded to figure that out by doing experiments with your business partner. So the two of you were...
Luke, I think Luke left. Luke stayed at Ottawa U for a year. And then it was basically I had to figure everything out
by yourself
on my own. Yeah.
So you were back to your cellar and doing it on your own.
Well,
full time.
By this time, I had a 2-car garage with a lab in it, and heated garage, and that's where you see the electric bike video. And so I had to. I had to go back to read everything and understand.
And you were able to put the story together that you were just explaining to us about impedance and what is that? Parasitic
capacitance, yeah.
And time delays and frequencies, and you figured it out.
Yeah.
Can I get out of the theoretics and to the human story? Because the $1 million question for journalists or artists coming here is, if you invented this and it works and you know why it works and you can build it, then why isn't it in your car? Which is the obvious question.
It will be.
And why isn't it yet? Is that because the prototype is not... You need serial manufacturing to get it working? Or what's the catch?
I don't know. Can you call God on your cell phone and ask him? Because
I don't have his number.
I don't either. And he's not telling me. So I don't know why. But I do know why. It's very simple. Have you heard of Stanley Meyer?
No.
Stanley Meyer, the guy that made the car that ran on water?
No.
Have you heard of Dr. Diesel?
He made a car that worked on diesel?
He made tractors that ran on vegetable oil. Okay? You've heard of people using French fryer oil in their Volkswagens? Okay. So Dr. Diesel invented the diesel engine to run on vegetable oil. So farmers could grow their own fuel. Okay? Like pretty significant. Grow their own fuel and power their own tractors. Like, give me a break. That's like pretty awesome. And so Dr. Diesel went to a convention in Paris and he won every award that you could imagine. And while he was going across the English Channel with his diesel engine, blah, 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 and all his awards, somebody pulled him out of bed, slit his throat, and threw him into the English Canal. And then his vegetable oil diesel engine was converted into a fossil fuel diesel engine. So now we're buying diesel instead of growing diesel. And Stanley Meyer...
But just a moment, this is the reason why we don't have this thing you invented in our cars, but why isn't it in your own car?
I'm getting to it. So Stanley Meyer built a car where you put water in the gas tank, and then he made a special spark plug that split the hydrogen the water molecule into hydrogen and oxygen, which you burn. And he made a car that you could run on water. And he drove it across the United States. And it's surprising that you don't know about it. So Stanley Meyer was murdered because of his invention. So let's say, just for argument's sake, that the universe doesn't want me to get murdered. Then the universe won't give me enough money to build something for my car or whatever. It will give me enough money to do the necessary research to define the physics, okay? To define the physics so that I can go to somebody from the Netherlands or Holland that cares about Dr. Oersted's discovery in 1820. So and a lot of people ask me, the same question: when is it going to be ready? When am I And I say, well, it's not up to me. It's up to the universe. I don't.
But the reason it's not ready for putting it into a car is that it's, not working 100%, or it's too expensive to build a thing that fits into a car.
The first part was we had to get the backing theory developed. That's the first part. Then the second part is we have to have a commercially viable coil. Okay? You can't.
That's logisch. Yeah.
No, well, I mean, if you have something that works, whatever it is, to make it commercially viable, you need to industrialize it, right?
Yeah.
You need to scale it up. You need bigger facilities. You need to bring the cost down.
Well, no, you have to make it so it resembles a conventional coil. For example, the first Regenex coil was 150 ohms DC resistance. Okay, the Dutch guys, his is 300 ohms. So that's a very high DC resistance coil. Okay, and you can't generate electricity with that coil. You can produce acceleration, but you can't generate much electricity because the electricity is consumed by the resistance of the winding. Okay, so it took us until, and when I say us, I mean me and my investors. It took us until 2018 to get a commercially manufactured Regenex generator coil from 150 ohms down to 0.4 ohms. Okay, 0.4 ohms. That was a very, very long and arduous intellectual property iteration process.
Want minder ohms, dan levert hij meer op. En dan kan hij daarmee iets bewegen.
So now we have commercially manufactured coils that are less than an ohm of resistance. So now they're commercially viable.
Right.
Now you can put that into a EV, or
and this you could have done this faster if people would have supported you with more money or research.
No. Okay. I'm going to hold a gun to your head, okay, Mr. Songwriter?
Right.
And you're going to write me the best song in the history of the world in 10 minutes. Okay, you ready? Go. Mm-hmm. No, doesn't happen that way. But if I say, can you write me the best song in the history of the world? You might say,
I'll try.
I probably could. But you're going to have to open yourself up to inspiration and so on, right? And your life experiences from that point on are going to they're going to be the basis for the song, right? So you're going to start out with an objective, and there's a certain amount of incubation period that needs to happen to produce that, whatever it is, and you're not in control of that. But when you have it, you're going to know. And then once, like I said inside, once you have it and you create it, you're going to try to put it out in the world, and the world's going to say, oh, you know, I love that song, or I hate that song, or
All right.
that guy's a bad guy, or whatever.
I think I might misunderstand you, or have misunderstood you. So I thought you meant with the story of Mr. Diesel that while you were not murdered, you were being opposed by...
No.
Okay.
No. I have never been opposed by anyone. I have been slandered and treated not well. But then again, anybody that starts a company that does innovation, I mean, if you know the story about...
So the reason why it's not there yet is not because you were being opposed, it's because it just takes time. That's what you're saying now.
Yeah.
Okay.
Yeah. It takes it took the Wright brothers 10 years before their airplane literally got off the ground. Alexander Graham Bell, same thing. Henry Ford, same thing. 10 years is the minimum. 10 years is usually the incubation period for an innovation. And so my company develops intellectual property, okay? So we have a dozen now. And the RegenX generator and the RegenX motor, those are only a couple of many. So while I'm waiting for the next inspiration to say, hey, change this on your coil and change that, and it often happens in a dream where you wake up and you go, oh, I have to do this, and then you go and you do that, and you try this and you try that.
But still, you were referring to the diesel story, and
okay, so inventors, and this goes back to those guys who don't want to talk to you, and it was
The Yoss guy. From,
just these guys who, so now we have the physics explanation, we have the commercially manufactured product,
Right.
we have the patent, we're filing new patents.
you can get going now.
Yes, and we are.
Right.
And as I mentioned to you inside, we have 2 car companies that we're talking to right now. I can't say anything more than that, but one of them is very big.
Right.
And I'm writing to...
And you've never been at this point in the history of your research. This is you're on the top of the hill now.
This is the natural progression of how it's going to go. And...
if you're cold, we can go inside.
No, it's okay. I mean, Google knows about it. I mean, I'm introducing it to Fisker. Fisker's going bankrupt. Lucid's going bankrupt. Rivian's going bankrupt. Even Tesla is having trouble. So the EV model, the existing EV model, doesn't work. You know,
We were talking about Mr. Diesel and the others, and you were saying it just took me time to get to this point.
yes.
But what is it? How does it connect the diesel story? Or it's getting to this point. Could this be a risk for you, or are you afraid of the industry?
No, because my priority is to rewrite the laws of physics.
To get this story out.
To rewrite the laws of physics, not to correct the existing laws of physics. To go back to 1820 and say, you know, the guy Hans Christian Ørsted, what he did in 1820, we should revisit, because he's the guy that made the most significant discovery. But because everything was in the newborn stage, people were not able to appreciate what he did. Now let me show you what he did. Okay. I wonder if this will work.
You have a compass.
This is aluminum.
Okay. We need wood.
Invented by Ørsted, by the way.
This
Aluminum.
Really?
Okay, there you go.
I googled this guy,
Yeah.
and one of the things in one of his achievements is
Yeah.
inventing aluminum.
Okay.
Anyhow.
So here we are with a compass needle.
Yes.
Now, can you please move that compass needle without using energy?
No.
You can't. You can't. You can't. Okay, turn that. Just wait. You don't have to turn it yet. Hopefully it'll work. Try it now. Maybe it's... Wait. Stop. Stop.
Stop.
Okay, do it again.
It moves. Yeah.
Okay. So that was his experiment.
Right.
So what happens now is the electromotor runs a current.
Yeah. So I think what he discovered is if you have a wire and a current is going through it, and you hold a compass needle besides to it, then the compass needle starts moving. So you can induce movement.
Field, the magnetic field energy. This is the key thing. The magnetic field energy around the current-bearing wire is going to increase the kinetic energy of the compass needle. Right now, the kinetic energy of the compass needle is 0.
Right.
Okay? Now, Newton's first law says, and the law of conservation of energy and the first law of thermodynamics, they all say the same thing. If you want to change the kinetic energy of this compass needle, you need energy. So if we're changing, I think there's a problem with this table, but if we're changing the kinetic energy of the compass needle, and we're using the electromagnetic field energy, then where is that energy coming from? And this is Ørsted's discovery that's just gone unrewarded.
Want waar zou die energie vandaan komen in de klassieke...
Ja, dus zoals ik het zou zeggen, denk ik, is er gaat een stroompje lopen door die draad. Hè? Je stopt met een stopcontact, maakt niet uit. Er loopt een stroom door die draad. Doordat er een stroom door die draad loopt, bestaat er een magnetisch veld om die draad. En het kompasnaaldje heeft ook zelf een magnetisch veld. Ja. Hè? Dus op het moment dat je geen stroom door die draad hebt lopen, dan ligt die kompas daar gewoon. Maar op het moment dat je er een stroompje doorheen laat lopen, ontstaat er een magnetisch veld rond die draad. En die twee magnetische velden interacteren met elkaar.
En wat er dan aan kracht vrijkomt, daarmee kun je dit is een ijzeren naaldje dan. Ja. Die kun je dan laten bewegen. Dat is de kinetische energie.
Ja, dus volgens mij is het magnetisch veld om de draad. Dat gaat de richting van het magnetisch veld bepalen of beïnvloeden van de kompas. En dat is ook hoe die kompas zich richt op het magnetisch veld van de aarde.
So, are you done?
Yeah, I think so.
So, Ørsted discovered the law of creation of energy in 1820.
And that is a new law that people don't know.
That's the new law that I formulated based on the positive work, because you have to identify the energy source that's making our system accelerate. Well, it's the law of creation of energy. But I didn't discover it. This is why you motherfuckers are here, to take this message back to your country and say, get your head out of your asses. We have, Einstein said energy and matter are interchangeable. Okay, everything is just energy in motion. Okay? There is no such thing as matter, it's just energy. Ørsted said energy can be created. That's his discovery. And it's a sin. Very, very, very big sin. And I have written to many of your professors, and I've said the kinetic energy change of the compass needle is equal to the work performed on the compass needle, which is equal to the energy required to perform the work.
So energy comes out of nothing, or out of the subatomic.
Energy is being created.
And we had a professor of physics, Mr. Koekoek, and he told, his main argument was this: energy can't be created; it only can be transferred in another form.
He's parroting.
He's not the only one.
Oh, of course, that's what they have to say. Now, if we said, now it gets even worse for the physicists. Okay, it gets even worse for them, or the electrical engineers, because Ørsted in 1820 built the world's first perpetual motion machine of the first kind. Are you there? Are you with me?
Yeah.
Do you know why? Tell me why.
No, because he showed there's negative work, etc.
There's positive work, increasing the kinetic energy of the compass needle, not decreasing it.
Yeah, okay, yeah.
With
no external.
Source. Like, where is it? He was using a battery. He was running. Now, here's what they'll tell you. Okay, the physicists will tell you. They'll say, and this is where they're tricky. Okay, what they'll say is, oh, you need energy to create the magnetic field. Because if you don't have a battery, if you don't have current flowing in the winding, then you can't have a magnetic field. So you need energy to create the magnetic field.
Which was my point toen ik zei je moet er wel aan draaien. Dan gaat hij van
Which is not true. So.
And you learned it's not true because at a certain point.
No. We're just going to apply Ohm's law and Watt's power rule. Okay. Do you have a electric stove at home? Mm-hmm. When you turn it on, the element gets hot. Mm-hmm. Okay. So it takes energy, electrical energy, which gets converted to heat to make your stove work. Okay. Right. So in Ørsted's experiment, the law of conservation of energy was being observed by the joule heating of the wire. Okay. Watt's power rule, the voltage times the current, tells you how much electrical energy is being converted to heat energy. Okay, it tells you exactly the number. And the conversion is being performed at 100% efficiency. Whatever heat is being created in the wire, because there's nothing else going on, whatever electrical energy is being converted to heat energy, it's being converted at 100% efficiency, right? Now,
so there's no room left to have kinetic energy.
There's no, again, your pockets are empty. You have no money left to pay for the energy to change the kinetic energy of.
So when the science guy says, but you need energy to create a magnetic field, you say, but all this energy is transferred to heat.
You need energy to perform joule heating. You can't. Now, here's the kicker. This is the smoking gun. Okay, if these wires were superconducting wires with zero resistance, you're still going to move that magnet.
Okay.
But you have no electrical to heat
There's
conversion.
No resistance. And therefore no heat.
No heat, but you're still moving the magnet.
At the same rate or the same?
The same, everything's the same.
So it's not related to the heat thing, to the energy thing.
But
the energy source is something else.
A physicist who's been, what do you call it?
Brainwashed, you call it.
Well, not.
Or trained.
Again, I was one of those guys. And, but
what would he say? What if he was this professor? What would he tell you now? Would he be baffled, or would he still have an argument against this?
So what I'm trying to do, okay, and I've been trying to do it for a long time, is electromagnetics, electricity and magnetism. What happened with Ørsted's discovery in 1820? The Newtonian mechanics guys saw it, okay, and they said, okay, Hans, good job, we'll take it from here. And then they took the electricity and magnetism subject and they put it under the umbrella of Newtonian mechanics. But Newtonian mechanics can't explain what's going on.
At the subatomic level, you mean?
Well, it can't explain the work that's being performed.
Oh, that's what you mean, yeah.
Like the negative work in a generator, the positive work here, especially in 2007 when we have positive work being performed with created electromagnetic field energy. That lets the cat right out of the bag, and you can't put it back in anymore. So all they do is they ignore the cat, which is now an elephant in the room. It's not a cat anymore, it's an elephant. And what I'm trying to do, and I've literally been trying to do with Dutch physicists, is say, look, you guys have the greatest scientist in human history that's yet to be discovered.
Well, he's Danish. You know, Copenhagen is in Denmark, but that's not a problem. It's near Holland, so.
Okay, I don't know.
No problem.
But
Dutch, Danish, anyway.
But okay, Netherlands then.
Yeah, we are Netherlands, but Oosted is from Denmark. Copenhagen is in Denmark.
Oh.
It's another country, but it's Europe. Never mind.
Oh yeah, you're right. Well, close enough.
Yeah.
For us, it's like Ottawa. Okay. Well, so I'm wrong there then.
You know, trying to turn this into a commercially viable product.
It is.
But is that a goal for you, or is the goal to rewrite the laws of physics and you don't care if it's commercially
you have to rewrite the laws of physics first in order to explain to people what's going on.
Because I talked to one other inventor, and I asked him the question, suppose Shell, the oil company, comes to you, says, we'll give you $10 million for your idea, but we'll put it in a drawer, and people will never heard of it. And he said, I'll sign. I do it.
He's a moron.
And you won't do it.
No. Again, the Wright brothers, when they created the airplane, they had to write the laws of aerodynamics. There weren't any laws. They had to write the laws of aerodynamics. So the best they could do was gliders at the time, and then the Wright brothers came along with their heavier than air vehicle. I mean, right? And they were pissing everybody off, especially the French glider guys, because now the Wright brothers were creating a heavier than air vehicle. And even imagine if we were in, like, let's say 1700, and I came to you and I said, guys, I want to build a boat out of steel. Okay? I've discovered the law of buoyancy, and I've figured out that we can make our boats out of steel. You'd be like, come on, Thane, what are you smoking? But they used to make boats out of wood because wood floats. Now, in order to make a boat out of metal or concrete, you can make a boat out of concrete. Well, it'll still float because of the law of buoyancy. So as our physics perspective grows, our knowledge grows, and we advance. So what I'm trying to do with world physicists is I'm trying to go back to 1820 and say Ørsted discovered, Ørsted discovered the law of creation of energy, but he also discovered the law of conservation of energy. He also discovered Ohm's law. He discovered Watt's power rule, all in his little experiment. And the guy, well, okay.
He's Danish, but he's forgotten.
Yeah, so he created aluminum, but what else?
My story also, it's a personal story. I'm telling I'm going into this story for 2 years now. It cost me a lot of energy and maybe even my relationship in a certain way. What has this venture cost you?
Your relationship with Yas, for sure.
With Yas, yeah.
Well, okay. So, if you want to take a trip, okay, if I want to go to California, then I have to be willing to give up living in Ottawa to do that, right? So in 2001, right after 9/11, I took a trip and I said to myself, I don't want to buy energy that's being paid for with the blood of soldiers and civilians in countries that have oil. I want to develop a peaceful energy alternative to oil. That was my goal. I had no idea how I was going to do it, but that's what I wanted to do. And in 2007, I discovered it. I rediscovered it in the acceleration of my generator. And through my evaluation and learning, I realized that I didn't discover it at all. It was actually Ørsted that discovered it, but I discovered the same thing but in a different format. And my discovery is such that it's undeniable and unavoidable. If you're fortunate enough to come for a demo tomorrow, I'm going to show you an electric generator that generates electricity at infinite efficiency, which means infinite efficiency means if you're turning it at a certain speed,
Yep.
and connected to a load, and this doesn't change, your input doesn't change at all, it stays the same, that's infinite efficiency. Okay? That means, so if you're turning this at a steady state speed, you're a drive shaft. At a steady state speed, the drive shaft is at what's called rotational equilibrium. And rotational equilibrium means that the torque and the torque in the drive shaft is zero. The speed is whatever it is, but the power, the mechanical power, is the torque times the speed, okay? So if I keep this going at a steady state speed and the power in the drive shaft is 0 watts, okay? Connect this to a load and it stays at that speed and torque, then the mechanical input is 0 and the electrical output is whatever, okay? If this now accelerates, now I'm generating electricity at infinite efficiency and I'm performing mechanical work, increasing the kinetic energy of the generator and the whatever's turning it. Now I'm operating as a generator at infinite efficiency and as an electric motor at infinite efficiency. And then when you...
But the first would already be great if it doesn't accelerate, but it stops.
If it didn't accelerate, that would be like, or decelerate, that would be like colossal.
Right, if it just keeps
Yeah,
going.
yeah. That would be like...
But it accelerates,
It
which is even
accelerates.
Yeah,
Okay.
if we were... So, if we lived in a world that wasn't controlled by emotional people, silly people with, okay, then that... You would know. You would have known about this in 2008 when we went to MIT. But there are, you know.
So what did it cost you? I ask you, what did it cost you? It soaks up all your energy, I imagine. It's your life. It's your life's work in. And there are people who are not taking you seriously, so it must be hurting, or it must be frustrating a while.
I don't care.
Did you lose friends, or did you lose...
Yeah. Yes, every friend, every relationship, just about. Yeah.
You lost it because of this invention.
No, because I'm a prick.
But you wouldn't be the prick because if you didn't...
Prick. I'm a prick. I'm a total motherfucking prick. My parents... My father was he's deceased now, but he was a chemical engineer. And he didn't like the research that I was doing. And my parents said, okay, you know, we're going to have to disown you because you're not a good son. Yeah.
Because of this thing that's right in front.
Research, yeah. But it happens over and over and over. It happened at Ottawa U, it happened at MIT. So...
And did your wife leave you because of this thing in front?
No. Yes and no. But eventually, when we went to MIT and when we got into Ottawa U, and my father, chemical engineer, came to the lab, and I said to him, I said, what's changed since, you know, when I was a bad guy, a bad son, and you had to disown me or whatever, and now I'm a good son and you're bringing your friends to Ottawa U because you're so proud. What's changed? What happened? Why did you guys change your mind? And my father said, well, we just realized that you're a belligerent motherfucking prick and you're not going to give up or change or whatever. So we had to. And that's basically it. So
And was it worth it being a prick? Like,
well, if I came to you and said, okay, I'm only going to do this interview if you stop playing the guitar or stop singing or stop seeing your children. I know you have 2 daughters. So if I said that to you, you would say, piss off. You would say, there's no way. There's just no way. So
people said that to you. Stop playing guitar, stop playing with the motor.
This, stop doing this, and
Or you won't see your children again.
yeah, that actually happened. Yeah. But so when you go on a journey as an inventor, okay, it's not unlike a songwriter or an actor or a...
It requires persistence and grit.
And you have to commit.
Right.
You have to commit. Talk to any inventor, Steve Jobs or Elon Musk, who sleeps at the factory. If you don't commit 100 every ounce of your energy, you're not going to succeed.
You have to put something of yourself in it.
Well, you have to. The universe requires that you commit, and the level of your commitment dictates the level of your success. If you commit 20%, then that's going to be your return, and you're never going to get what you want. If you commit 100%, and that means you don't get you don't have a plan B, or you don't have an extra job, or you don't do those things, and you rely on the universe to bring you investors and so on, and that's the way you live, then ultimately that's how you're rewarded. But if most people, they don't understand. I was a high-level chef, and one day I went to my girlfriend and I said, I'm quitting my job and I'm going to be an artist. And she was like, what? And I spent the next year producing my portfolio and then painting. And the next year I was selling my art and doing art shows and making $10,000 a day or whatever.
And she was still your girlfriend, or she?
Yeah.
Oh, okay.
Yeah. And then I had an opportunity to buy a restaurant, and I bought a restaurant, and I almost went bankrupt after 2.5 years, and I didn't give up, and eventually I had the restaurant for 7 years, and I was making lots of money. But that's the way it works.
Are
Commitment.
you worried that someone will replicate this and walk away with this?
Somebody already has. Lots of people have.
But steal the idea and make it commercially valuable and cutting you
Successful
out.
and famous with it. Well, nobody has ever heard of THANE HEINS.
Well, you said something interesting. You said in one of your emails, the ever
Omnipresent.
omnipresent. How did that come? What
Well,
was that about?
I found you because I just started Googling the subject of these, and I found your name everywhere.
These
And
crazy people. Doesn't want to say it.
no, I stumbled upon crazy people
Yeah.
in the comment sections. Then there's an article or something about it, and then you go into the comments, and then you go down the rabbit hole.
Yeah.
But your name is turning up in so many places that
Eventually,
you were the go-to guy.
Eventually, it's just a matter of time. Again, when Alexander Graham Bell invented the telephone, okay, imagine he's said, hey, Alexander, what are you doing? He said, well, I'm working on a thing where I'm going to pass voice down a metal wire. People would look at him like he's crazy. Like literally, he must be crazy. And in fact, he said in his memoir, he said he was terrified that they would come and put him in a straitjacket and take him to the insane asylum, because what he was trying to do was so out there. And so he invented the telephone. Then he took it to the telegraph guy, the owner of Western Union or whatever it was at the time. Went in his office and put his telephone down on the guy's desk, and he said, I want you to use my telephone. And the guy laughed at him. He said, why would I be interested in this toy? It's just a toy. And Alexander Graham Bell walks out, and he's like, okay, and puts the guy out of business, puts the telegraph out of business. So that's the...
So the question was, are you worried that someone will steal it? And you're saying...
steal it if you want to. Like, look, you must understand how close we are to nuclear war. We're like seconds away. And much of that worry or much of that anguish is energy related. Am I out on a limb, or do you agree?
No, we agree.
Okay. Since I mentioned it, Japan got involved in World War II because the United States cut off their access to oil. So
You're saying even if your ideas are being stolen, then it's for the better of the world and for the history of humankind.
yes, but
Are you worried that someone will try to hurt you in any way because of this?
no, if you guys go back, even though you're not, even though not from Denmark, I learned something today. If you do your jobs and you sell the story or whatever, get the story out there, then once the physics are changed, you can't go back. So that's my primary thing right now, is getting the physics changed, getting the physics corrected. There's the law of conservation of energy and there's the law of creation of energy, and they can coexist together. And when you come tomorrow, I'm going to show you an electric motor that performs any magnitude of work with that much energy. Zero energy.
Right.
Zero external. This on steroids.
But if your primary goal is to change the laws of physics,
Which
the understanding
I've already
of that,
done. Which I've already done.
but to make that known to the world,
Yes.
if that is your primary goal, are you in contact, or you're trying to get in contact with people that could do that for you, with the big universities or the established research world?
Yeah.
It's a
Yes.
quantum leap for these people. So
The problem is, that every physicist, every electrical engineer, every mechanical engineer, every engineer that is involved in electricity or motors or anything like that, they have to go back to school.
Yeah.
And they have to relearn everything, which they don't want to do. And also, the scientific community has to admit that it fucked up big time, and it it's teaching fake science in universities. The student,
but not willingly. That's where I
not knowingly, but some are. I mean, at Ottawa U, okay, Dr. Abash came to me and said, "Thane, I have 5 third-year engineering students who are all going to fail." And he said, "I want them to replicate your generator and get them to write a report, and you help them write a report, and so on and so on." So the 5 guys came, they replicated the generator coil, they created a generator coil that accelerated under load, they wrote their report, and I helped them edit it and yada yada yada. They confirmed everything, data and everything, and they all passed. Okay, they all got their whatever degrees. And while they were working, they said, "How come we're not learning this in our class?" And one guy said, "This should be part of our curriculum." And I said, "Well, go talk to your professor and tell him to come for a demo." That was the guy on the 4th floor, or whatever, the 2 floors above me. And he wouldn't budge. He wouldn't budge.
Dit was het tweede deel van ons ongemonteerde gesprek met THANE HEINS, de Canadese uitvinder. Fragmenten van dit gesprek hoor je in de spannende podcastserie Het Apparaat. NPO Luister, Human en natuurlijk in je favoriete podcast-app.